Overcome the real-world challenges between data and AI. Hello, everyone. This is Stephen Yuan, CEO of StorageX.ai. Welcome to SNIA Compute Memory in the Storage Summit 2024. In the past century, we went through a lot of technology cycles, all the way from mainframe to PC to networking to desktop internet, so-called Web 1.0, and mobile internet as well, Web 2.0, and the cloud and the SaaS. Today, we're seeing the significant cycle that is coming, so-called AGI. We call it AI 2.0. During this cycle, we are going to see a lot of changes into the business models, technology developments, and things that could change our life for next decade. So in past 20 years, the CPU and the GPU growth basically follow the Moore's law and start to slow down recently because of the scaling issues. And the data itself, however, is growing much faster in a rapid case. Basically, it's followed the exponential growing pace that because of all the things that I mentioned above, because of IoT, because of mobile internet, because of cloud business and the new applications coming from AGI or tools that are needed to train large language models, etc. So by looking at these, we're seeing that per data volume, the compute resource is really decreasing. Despite the piling of the resources being used for training the large language models, for example, GPUs and other stuff, that needs a lot of silicons and devices to be used, but the data has been generated by the lifetime and by the devices that were used and by the smart factories and by the smart vehicles that are now running on the road is more and more. So we're really seeing that the bottleneck being pushed back to the hardware stuff, for example, compute, network, and storage itself. So the ideal hardware or compute resources is able to grow as fast as the data itself. So this is being the architecture being used for decades because of separation of the compute and the storage nodes left on the GPU, left for the GPU and the CPUs, right for the storage, and the data being moved around these nodes with data size being growing really fast. It creates really heavy traffic and a low latency itself for the applications. The network becomes more important, and the so-called and because it's more important right now, and narrow down to the compute efficiency. It's really proportional for the computer power, data acceleration, I/O bandwidth, and the negative impact comes from data volume and moving distance. So with that being said, moving compute and to closer to data and the return results become more efficient to lower the traffic and lower the latency. So data-centric computing is becoming more important. So this is an example from the process of training or ChatGPT and such for a large language model. Step number one, supervised learning. So we need to collect a lot of demonstration data and train a supervised policy at the beginning point. This data being used to fine-tune the models with the supervised learning, and then use that data for the reinforcement learning that collect comparison data and train a rewarding model. That rewarding model being used, and the labeler can rank the outputs from the best to the worst. So that process is used to train the rewarding model. The step number three, proximal policy optimization. With that outputs, new property is sampled from the data set. And that policy against the rewarding model use the PPO reinforcement learning algorithm. That policy generates an output, and the reward model will calculate the output from a reward for the outputs, and then reward will be used to update the policy itself. So this is a very iterative process from beginning to the end. This requires a lot of data movements and the compute resource as well, because the data is getting bigger and bigger and the process is getting more complicated. Another example is the smart factory. That's a real world case that intelligence is needed for the efficiency. Back to the old days, automation was very important for the factory itself because of the cost reduction, because of the improvement requirement for the production life cycles and factory capacity itself. And that be used to reduce the labor cost. And later, that digitization has been used for these factories. Tools like ERP, CIM, MES, mass systems, and hardware like IoT devices and edge clouds. Those use the data to achieve the intended product life goals, production goals, or operation efficiency for the better business decision making. However, recently there's a development of smart factories applying the artificial intelligence, use the intelligence for self-monitoring, automated problem solving, identification solving, and management, etc. So this has been used for the lighthouse factories to achieve high capacities, higher yield, faster problem solving, shorter life cycle, and more flexibility, etc. So next slide, I'm going to talk about real world challenges for data and AI. In terms of these machineries, automation tools, in particular for AOI, it's automated optical inspection tools. It's going to generate a lot of data, especially images that are being passed through the network and saved on the storage nodes or data nodes on the SSDs. And these data will be used and transferred through the network and be used for the analytics processed by CPU and GPUs. So the real world requirement is it creates a big data set. There's a lot of large amount of data being generated, from those machineries, and millions of files per day, and accumulated petabytes data per week. So each file could be a gigabyte size, 80 billion, and less than a second for the decision making. So that challenge to the infrastructure will be storage and in terms of write time, IOPS capacity, network in terms of latency, throughput, moving distance, and the compute is process time. It all impacts the decision making stuff because of the short cycle time. Some of the decisions need to be made by seconds. So that's why that's a big challenge for the real world hardware stuff. So similar, a solution is proposed to do that is transferring the AOI and automated tools data to a data and network AI processing devices all combined that are able to generate some results before being saved on the SSDs, and then can be processed through the time when it's idle or when it's sitting around for the further data mining and data processing. So it creates a opportunity that able to process the data, real time that's been transferred in, and also the opportunity is to process that data afterwards. So without transferring data back and forth from one server to another, especially between data nodes and the compute nodes. So and the end result is creates a faster decision making process, storage, faster write time, shorter data paths, network, lower latency, less data movements, and compute fast processing time. So this is a benefit, to the smart factory, and these real-time data analytics will be required for the key factors, including lower latency data fetching and pattern analysis and faster combinability study, to find the results because of the data feeds from the machineries are very big and fast and important. So at the end of the day, faster data-driven decisions will result a quicker failure identification and problem solving. And to the process itself, we sometimes we see a lot of like hundreds process, during the whole manufacturer chain, and there's a lot of machineries involved. So find the issues will be very important, and to result a higher yield and faster ramp-up time. So quicker failure identification is very important. So with that being said, um, each capacity, each factory calculates the margins based on the capacity times yield and minus cost. With that, with this type of process being implemented, that we're going to see a very high yield and a faster yield ramp time. So that creates a lot of spaces for net margin for the factory itself during the product production cycle. This is a whole holistic architecture from infrastructure-wise all the way up to the SaaS platform that they're able to learn to run this data collection, process monitoring, retrieval yield analysis, and processing movement based on the hardware that built for faster data processing itself. So we call it a smart data lake API. The infrastructure itself will collect the data and save the data on the servers or data lake that able to be analyzed in the real time. That factories could be across the different industries: LCD panels, foundry, solar, and batteries, 3C products, etc. So this is very important in terms of the industrial data mining in the analytics platform. Next step, with that being said, all data being saved on the smart factories that creates a big data set, and combining a vertical large model, which is next step for those domain-specific applications. That even better for the better intelligence for the those factories to create a better business intelligence. Smarter business decisions can be made through the process. So the conclusion, data-centric computing is really important for the data-intensive workload. Today we're living in a world that is full of the data. All those mobile devices, vehicles, and the machineries generate a lot of data. So this data can be used to create better productivity for smart and intelligent factories. Data can be very big and fast. We need a better architecture to handle this. Pose the big challenges to the infrastructure because of the data-heavy workloads, compute network, and storage will be challenged. So compute and near data can be used and can be very important to solve those issues. Lower latency leads to the faster cycle time and leads to faster business decisions and better efficiency, higher yield, lower DPPM, etc. So vertical large models can be very important in the next step for the domain-specific areas. Data can be accumulated, analyzed, but not sitting long. AI-powered commonality studies represents a significant advancement in terms of identifying the patterns and similarities within large data sets versus scientists or engineers doing that. So it's the fast processing becomes more important than ever. So we needed to look into the new architecture and opportunities to improve those processes. All right, so this is a wrap up for today's talk. Please take a moment to read this session. Your feedback is very important to us. Thanks, everyone. See you next time.